Next time is the special lectures. Next slides. Okay. Special lecture 4. This is topic. Its topic high-speed computing and communication. Is the speech by the Professor Dongseung Kim. Dongseung Kim is a professor, emeritus professor, Korea University in South Korea. Okay. Next slide. Yeah. Next. Oh, he's a graduate school of energy and environment, Korea University, South Korea. Next slides. Okay. As you see, he's a Seoul graduate of Seoul National University Department of Electronic Engineers in 1978. Graduated from the Electronics and Electrical Engineering Department of the Korea Advanced Institute of Science and Technology in 1980. Highest full-time instructor at the Gyeongbu National University from the 1980 to 1983. Department of Electrical Engineering Systems, University of Southern California, Los Angeles, USA, 1988. Associate Professor of Pohang University of Science and Technology, post-doc in 1989 and 1995. Professors at Korea University from 1995 to 1920. This year, he's retired. Is it right? Yeah, congratulations. Okay. And so members of his research group are working on cluster computing and parallel computing as applications. They are interested in parallel algorithms, internet computing, and faster interconnection design and parallel programming. Thank you so much. Yeah, please. Yeah. 그래서 여기서 하시겠습니까? 보자. 여기서 해도 될 것 같습니다. 예.
Okay. Thank you very much for the introduction, Chairman. I think my title is a little bit digress from this subject, but I hope you enjoy and relax because it may not be your major. Okay, the topic is high performance computing and communication, and this is presented at this international workshop. And I'm Dongseung Kim from Korea University. 다음으로 넘어가는 게 포인트로. Okay, this is funny picture, and my talk is about the parallel computing. If you drive a car in the highway, if you have only one lane, then it may take time to pass some point. But if you have multiple lanes, then it's a lot easier and efficient. Computing, parallel computing is like this. Use more resources, more computers to have better high throughput, high computing power. Okay, I will talk about the background of this information, and I will introduce recent computing demands, and the main topic about the high performance computing machine is introduced. Usually it is called cluster, and recently to more speed up, to have more speed up, the GPU general purpose graphic unit is included in the computing area. So I talk about a little bit about that. And finally, I like to introduce, even though it's not in your field mostly, the way to program, how to program the parallel machines. So a brief description and examples will be given. Okay, firstly about big data and clouds. We need more and high computing power recently because of the big data expansion, and many data are shared globally, and the network is highly used these days, like SNS or the some kind of video sharing and so on. And we also use many programs and machines for intelligence and automation in such as banking, future autonomous driving, entertainment, and so on. And we received a personalized services from computing or portal companies. So that requires more computing power. And also, we are concerned about privacy, security from the phishing, virus, spam, and so on. So that are all these kinds require better and high-speed computing. Uh, Recently, we used the term smart everywhere, smart living, supported by the IoT sensors and cloud computers. So they called ICBM. It's not the military term. IoT, cloud, and big data and mobile computing combined together to get very meaningful and useful results. So, for example, smart home, smart automobile, smart factory, and so on. So we can easily think about the what they are doing for our life. So this shows in the shows the pictures of this smart something over here. About your field, the smart grid is one of them. Smart health, smart home, smart cities, and so on. Computing side, the fast and big computers supplies the services like IPTV, video on demand, and we use the uh, cloud service for changing data and sharing data. And often we use our telephone, mobile phone, to talk with our friends or to get some data from the cloud or the shared data source. And some of them, I think many of them use the computing power of the cloud. For example, if you speak something from your telephone, then that speech signal is given to the cloud, and the computing is occurred there, and the result is given back to you, like using a smart speaker or driving program that understands your saying. So that is an example to get the services from cloud. And cloud also provides some utilities or programs for your use. So you can connect and use it anywhere without worrying about installing your program to your computer. And this is a funny figures taken last year, I guess. That shows the generation, the telephones changing generation by generation. The left side, the leftmost telephone was the first phone I used about 20 or 30 years ago. Yeah, longer than 20 years ago. The believe it's a second generation phone that use both analog signals and digital signal. And the middle one is the one that only use digital signal for the communication. And the next one is more recent one. And at the right side shows my PDA. The term PDA may be unfamiliar for you. It was some kind of memorizing pad. I put the telephone number of my friends, or I use some calendar-like function to record to memo my things to do or schedule or something. In the right side of that bottom pictures, there is a calculator. Yeah, it's a little bit bigger than the PDA, but those are the things used about 30 years ago. Now you don't have to remember, or you don't have to have such kind. Why? Because our mobile phone has all the functions we need, even the music player, MP3 player, included in your telephone. So we are living in that stage because of the changing or the developing of new technologies. So about the speed of the network of cellular phone or mobile phone, we start from first generation to fifth generation now. And during that time, the speed of the communication changes from a few kilobits per second. Now we are heading toward the tens of gigabit per second. So that speed is enhanced by about million times. Yeah, in 20 years, our speed goes up. In the early days, it was not easy to send text to my friends using my phone. But we are now we can send pictures, even moving pictures. The video can be transmitted through our telephone. So it's a new world, if I remember the old days. The satellite internet will be possible by the end of this year, as they announced that the SpaceX at the bottom. There is the company founded by the Tesla manufacturer. The satellite internet, it has a big advantage in terms of the delay of our data. The voice. If you have a long delay in your voice, as we experience in our video conferencing right now, it is very uneasy and difficult to talk to each other smoothly. In case of satellite internet, if we use like the geosynchronous data for the satellite used for broadcasting, that it shows it is on our above our head, and it looks like it is not moving because it rotates synchronously with our globe. But it is far away, so it's like 36,000 kilometers. So the delay in the wave, the propagation delay is very great. So it's like 270 milliseconds. But if we use the low altitude the satellite, the height is 550 kilometers, is 1/20th of the geosynchronous satellite. Then delay is like 1/20th. So delay is reduced by 20 times. So it looks quite easier and natural if we can use that service. And it also have the advantage of covering anywhere in the globe, in our Earth, sea and remote mountain and so on, and desert also. And another good point is that it can be compatible to our current telephones and other machines. So you don't need to change anything. Just using like a Wi-Fi in the room or in your place. But there is a bad side also. So first one is it costs very much. The company tells that they will need like 100,000 satellites moving around close to the globe. Because 100,000 is a very big number. And because there are so many satellites, the wave or the electronic signals may interfere other communication devices. So that is another problem. And maybe we think about the collision, and when the satellite ends its life, then it will drop to the ground. Then we have to worry about how to avoid or how to make them safer to the people. And one of the company trying to invest and currently building this network is called SpaceX. And they said their internet will be operated in mid-2020. So it's about the time, but I have not heard that they are in operation now. And in the old days, Amazon's, Iridium's, that kind was announced. Okay, we are living in this time like this. Okay, about the computing, what functions do I use in the computing called the cloud? The computing service is the major one, and another is the data storage and share. And with that data, we can collaborate without any limit in our place or in time. And data can be stored, and we can dig out anywhere in the world. And synchronization can be done through the cloud. And many applications can be used either free or paid. Now we are using our computer at hand because we are having mobile phones, and the computing capabilities like the supercomputer in 30 years ago. So it's in our term is greater than gigaflop computing power. Gigaflop. 1 giga is billion times operation, either adding or multiplying and so on. So that small phone can compute the amount that was like the supercomputer in the 30 years ago. Yeah, with this cloud, we can communicate using social network service, on-demand video watching, and so on. Uh, if I use a searching function in the internet, what do the service as afford? What kind of function do they use? So the searching company like Google or Amazon and so on, they will collect so many data around the world automatically. They have some kind of program. That program does reading web pages uh, uh, anytime, every day, 25 or 24 hours a week, and so on. So they collect information, but that's not sufficient. They need to organize it so that some keyword is given that could be searched very fast. So we call it as indexing. So analyzing some document, we pick up some useful keywords so that that keywords will be used for the uh, searching query. So that was stored, and once some keyword is given by user, then query matching is done after that time. Usually we call this string match. And in while this service is done, then some kind of database operation is added there, and that is usually called query processing. But the real uh, process is quite complex, so I cannot go to details of that. But many other operations are combined so that we can get the search result instantly. We hope our search result is coming back very fast. So we need to get very fast response. For that purpose, the company should have a very fast machine to support the user's need. So reduce the execution time by collaborating with multiple machines together. So naturally, the machine called parallel or distributed computing machines are needed. So that will help giving a quick data exchange and give more reliable and better prepared for any situation. And that will give the availability anytime and anywhere. And usually they also provide friendly, user-friendly service so that it can be used without the knowledge of what's going on in the computer. So how can we build that kind of fast computer? So we add up the power from a small computer chip. So that is called cores. So if we have many cores, then it's better than to have a small number of cores. That will give speed up and more efficient computing. And it also needs a high-speed network. 5G is one of the example of that. So high bandwidth and high speed. Another issue is to have good software for job management internally, so that they can schedule or partition or allocate their resources to be used efficiently, and so that any user does not feel uncomfortable in waiting and giving more request because it has long delay, and it will also give the easier use of the software. So in the early days, we have small number of computers computing individually. Now, after 70 years from the first computer, we are gathering those computers together. So that was possible by using the integration technology called VLSI, and that products gives the low cost and high performance and small size. Even it is gathered tens of millions of cores together. But that kind of big computer we call the supercomputer still needs a big space to install. I will show the pictures later. So in our term is power computing. It is feasible and indispensable technology today, and get big performance enhancement, but transparent to users so that we do not hear how many computing cores I am using. We don't know about that. We feel just it's very fast. We use technology used from 3 decades ago, so it's a long story. And the parallel computing is applied recently in many areas. But the problem is that it's not easy to program. Yeah, that's the problem. Because we are trained and we think one by one, serially, but the parallel means many things are going all together at the same time. So we like to overcome the current speed, and parallel computing also allows many problems that we cannot do before, because we did not have a small computing power, small space to store our data, and so on. Parallel computing also enables new tasks that was not exist before. So one example is that we did not think about games, or the we experienced the AlphaGo a few years ago. That was not possible if we didn't have enough power to compute. We can solve large problems, and we can solve the same problem faster and more cases. And parallel computing also enables us to have the resilience, some kind of the survivor, even though we have different difficult situation like earthquake or flood or something. Because if some of them is gone, then others can do work, even though the amount is small, but they can still exist. So that's another example of the good nature of the parallel computing. Theoretically, the parallel computing was used in many levels of our computing. So if I think about the hardware, the chip, inside they work one by one. The minimal operation is called the instruction. So instruction can be executed altogether if they don't have if they do not rely on each other, then they can go parallel. So it was used from early days, and we can run several subprograms altogether. the assumption is that they do not rely on each other. And task level, job level, even the user level, if I use it, you cannot use it because it has only one. But we have several users today, and they can work at the same time together because the computing can provide all services to everybody. So that is possible by the fast and good paracomputers. Okay, how do we realize this parallel computing machine? It is called the cluster. Cluster is, in our field, is terminology. It's a collection of computers that can give more power compared to a single computer. So cluster computer is practical way of building high performance computers. It is collection of computers interconnected via high speed network, and thousands, even millions of processors cores are included in there. And often it was computing accelerator, GPUs combined together to have a better performance without much investment. And it enables us big space to fit my big data together. So this is the way to build a big computer recently. So if you have a chip, then you may have one or two cores inside. Then in the board level, if you put many chips in the board, then bigger collection will be made. Now you copy the same board, like hundreds boards, and put it into a cabinet. Then it becomes a better collection, more collection. Now you have a big room installed by a lot of array of cabinets over there. Usually the size of this is like this room, the size of this room, like 20 meters by 20 meters. Then you have this big machine room over there. This picture is made in 2000, early 2000, and the name of the project was the building of Blue Gene, and it is famous because this was the computer to compete with the people with for chess, Western chess. So this was applied to that purpose, and the goal was to compete with people. So it is a only AI machine there. Actually, the newer AI machine was built by the IBM together, and that was applied to the AlphaGo recently. AlphaGo like game program, yeah, big game machine over there. Okay, this is another view of building real machine. And this picture is old, like 1 year ago. So it has the performance of the petaFLOPS. Peta is 10 to the power of 15. It's very big, huge computing power. And you can imagine the size of the cabinet over there. And that was installed in National Lab in the United States. And so that was the first link, the superpower, the first rank in 2019, and called the Subwin machine. And that is built by the cloud. Okay, let me see. We have the measurement each year for 500, the fastest 500 in the world. It's called top 500, the organization has the name, web page name Top 500, and they use the same program, and that is distributed any country and anywhere if they have big power computing machines. Then they run the same program and get the result and return to the organization, and they list up the top 500 computers each year, twice a year. So the most recent result is given over here, about 10 computers, and the first one, the topmost one is called Submit computer machine, and that was built by IBM Czech, and it is in the United States. And the power is 148 petaflops. Petaflops is 10 to the 15th power, then it's 10 to the 17th power per second. In 1 second, that many computing can be done. Surprisingly, they have like 2 million cores in the whole machine. 2 million. It's very big number. So this is the technology to get big power. In the old days, they tried to make one chip very, very fast, but nowadays it cannot compete anymore. So the more cores, the higher power. That's the rule of these days. And also to get speed up more, they use the hardware called GPGPU, general purpose graphic processing unit. It's a small size, as you see in the picture, in the palm size, and it has power of like, I cannot see it in the bottom, 15 teraflops. Teraflops is about petaflops times 10 to the 3. So it's like a 10 to the 12th with power. So one GPU supplies that kind of computing power. So if you use 1,000 machine of this, then it will give petaflops a second. So that is the new, not very new, but that's the way to more enhance the computing power in the fastest machine these days. GPU is not superpower. It has some kind of good work, and it cannot do useful work in some cases. So for such cases, our traditional chip, the CPU chip, can do the same. If they are fitting to parallel work, then GPU will perform much better. This diagram describes the internals of the GPU. So it has many processors inside, and also the RAM space altogether. Then they are connected. So in one GPU, as you see in the previous picture in the palm size, there are like 1,000 or 10,000 cores inside. But the core itself is primitive. It's not the core used in our general CPU, but it can work very efficiently. Now, it's the difficult part of my presentation for the parallel programming. But
you don't have to worry about just look at what's going on or what points are there compared to our previous programming technique. And actually, this presentation slide was borrowed from the Dongseung, who was in the Texas Advanced Computing Center. So using the parallel computer, we want to have better computing power. So if you put like 8 processors in your system, then you expect to have 8 times better performance. But usually it's not that great. So if you use 8, then the speed of figure is like 6, because in your program, some part can be parallelized, but the small part cannot be parallelized, and then you cannot achieve even though you have many chips, you cannot achieve that performance in that area. So this looks good performance, but some programs, some applications may not have that big achievement in the parallel computing. So it depends on your job or your task, whether it is good for parallel computing or not. When we use parallel computer, we write a program. Then they are called SPMD style, and that is the abbreviation of single program multiplicator. That means you just write one program, and if you have 10 computers, that same program is given to 10 computers altogether. But the data can be divided differently. So the actual computation can be done in separate data area, but the computing itself is the same. That is for the SPM, the computing style. So this figure shows that. So we just write one program, then it is compiled and given to different processors. So in achieving the parallel computing performance, we can classify the 2 parts for the nature. One is for the data parallel application. The other is task parallel computation. Data parallel means we have big data, and they can be partitioned into like a 2 by 2. Then we have both different area of data. Then computing is given to each of them, but the computation itself is the same. So we work on different data, but in all, we finish all together. Another type is called the task parallel computation. So if you have your own computer, you have many different programs like web browsing, the music playing, picture editing, and so on. They can go together. So if you have separate processors, then you assign one to the text processing, another to music playing, and so on. Then it's called parallelism. So parallelism can be divided into 2, but they can mix up together so that we can manage to have speed up and performance. This shows the one example, very primitive example. So if you have a job like this, then the center part is doing something, then the rightmost part is doing something, but slightly differently. But it is for data, so for data parallelism, so the work on the data part is different. So in this case, we have 100 iteration. So the first half of 50 iteration is given to CPU A, and the remaining 50 operations given to CPU B. So they can go together to speed up the computation. This shows the abstract abstract figure of the task priority. So CPU A does some task A, but CPU B does some other task B, while CPU A is doing, so they do different job over here. And this is another concept in our field. If you build a parallel computer, there are two styles. One is shared memory based parallel computer. The other is memory is not shared at all, but they can talk together through the network internet. So either you have this one or this one. These days, they mix up together and they have a hybrid model together. But if develop a parallel computer, you can use this one or another one. Why do we distinguish these two? Because the programming style is slightly different. So the language or the function used is here for the OpenMP style, and this use MPI, message passing interface. So we have the two different kinds. But if you are familiar, then you can go one to the other. But you need some knowledge. Okay, hybrid system figure is shown over here. Okay, OpenMP is what? It's based on the thread. It's another terminology, thread. It's a small size the program you generate. It's thread based on. Shared memory codes mostly data in parallel, and Open is standard for shared memory programming. Okay. So this is the example of one OpenMP program. So you have a iteration from 1 to 128. So if you have one processor, then you repeat 128 times to finish. But if you have two hardware, then depending on the situation, the CPU 0 will do the first index of the error code, and CPU another CPU will do this index 2 of the computation. If they finish, then they will continue for the remaining work. So if they diligently work together, then you will save the time by half using this style of computation. Okay, this NPI, the message passing interface style, and it is applied on distributed memory system. And okay, let's look at the figure over here. So they are separated. The distributed machine, each individual computers, they are interconnected together, so they can exchange, but the internal data is private to each other. So one example, okay, ignore this. If you have some model of computation to solve, and that model requires some data in the neighborhood, then the data can be exchanged by processors in the neighborhood. And their data in charge is different. Depending on where the processor is, you will have your own data. So they are not shared. But if you need some exchange of information, then that is possible using the network. So one kind of simulation example is given over here. It's called the weather simulation or the ocean flow simulation, something like that. Then we have a surface of rock. We need compute everywhere. Then that compute, the area is divided into even number of parts, and each part is given to different processors, and they compute their own and exchange data with the network, and computing can accomplish. So in case of NPR star, they have some kind of the, what is that, library functions to use. The other part, the black part, is the same as writing a C program you usually do. Only this part is included in extra as an extra functions if you need somewhere. So that is different style. One major functions they use is the communication function called send or receive. They put some mark, MPI mark in front, but the other part is the same as we use in the many send or receive. So message is some kind of data to exchange. So if you have two processors, then you can communicate using message passing. That is function supplied by the NPI. But if you don't need it, then you do by yourself, as you did using the sequential program. Same. Only communication part is different from your traditional computing style. So this shows another real example of the parallel computing using MPI. So in this light blue part, depending on your ID, so ID is given to each processor differently. So if I have an even number ID, I will do the top parts of the program NPI send. If you have a odd number ID, then you will execute the bottom part of the light blue part. So one part is sending, the other part is receiving. So communicating, of course, depending on their situation. And if you don't need communication, then you will do whatever you do. So this green part is the computing required computing part you program as you do normally using a sequential programming technique. So this shows very shallow form of the parallel computing. So one is using the OpenMP, the other is using MPI. So depending on your machine, then you will use one of them. Or depending on your hybrid computation, then you can combine together. Okay, this is the final slide of mine. If I comment on the future high-performance computing, the demands will increase for more computing power for new applications, and huge data explosions needs more power and speed of processing. And accelerators are rapidly growing for cost performance and high power efficiency. And more power will better and easier applications in the future. So, okay, I like to end my presentation. Thank you.
Thank you so much,
Yeah.
Professor. Yeah. So, okay, so catch it. Okay, yeah.
Yes.
Okay. Thank you for your great talk, and it is a really interesting book as a computer scientist. And there are several ways to improve the performance of computing. So you mentioned about the super computing, also distributed computing, and parallel
Yeah.
So I wonder what are the differences in them and how they will be connected in the future.
What do you compare to the
The supercomputing
supercomputing?
and the parallel computing
Uh,
and distributed.
they're about the same family. So the goal is the same and the techniques are different. So the way to build the computing, they are slightly different, but their objectives are same. So they are all going together. Maybe someday they combined to one, but for the next 10 to many years, they will go in parallel. So, yeah.
How about the parallel computing and distributed computing? They are different and how they will be connected.
Yeah, thank you. In my opinion, the parallel computing means the collection in the small distance areas, like in this room. For the case of the distributed computing, you use this computer and your friend's computer connect together and do the job at the same time. That is the concept of distributed computing. So internet easily gives you distributed computing without knowing yourself that I'm using others' computer or so. Distributed computing is provided. But if you have an intensive job to compute by yourself and alone, then you may use the parallel computing concept. That's the difference with different description.
So another question or comment? Actually, our setup is the focus on the three categories. One is the power system. Second is the communication system. Three, and the computer system. Because computer system is essentially based on the communication and energy system, based on the essentially. And so maybe thank you so much. Another okay, the time is some for break. Please,
I have a question
Yes.
for your turn.
communication system.
Do you think what the bottleneck for high-speed computing using parallel computing? I think it's ever the next is application performance for algorithm for networking, everything else.
It's very difficult question to answer, but there are many respects and points for the bottleneck. If about the algorithm, recently we use the deep neural network and so on. That's the improvement from old days in terms of the speeding and algorithm. And for the building technology, we are heading more power to better and better. But if you know the theory of Moore's law may be one of the block for our further performance improvement and so on. So there are many places having some difficulties and limits in our better computing area. Thank you.
Thank you so much. I hope the discussion is everything time. So, okay. Thank you so much. And let's take a break.